Welcome to September, new school year. New school year started. Welcome to be here. Yeah, thank you. So I see a lot of new faces, a lot of old faces. It's good to have everyone here. Before we even get started in everything, the very first question we always ask is, who is hiring? Is anyone hiring? No one is hiring. Okay, so if you're watching this virtually and you are hiring, or if you're watching this in person and you're too shy to say you're hiring, go to nyhackr.org. That's our Meetup website. On the top right-ish is the Slack link. Join our Slack group. In there, there's a channel called Job Postings. Post your job in there. It's usually people post a lot of jobs. In fact, Eric, you usually post jobs. You just have nothing to announce.
This is not my company.
Okay, fair. But Eric's often posting jobs for other companies because he knows people. So if you know someone who has a job opening, post it in the jobs channel. You know, this community for many years always have really good luck getting people jobs, so let's keep it up. So post the job online in the jobs channel. Next most important matter of business. The pizza is from Roma. So I'd like everyone to pull out their pocket computers and go to bit.ly/pizzapull. My regulars know what you're doing. All my newcomers are like, what's he doing? You got to go there. It's a very simple, plain website. You got to rank the vote on the pizza. It's a 5-point scale. Just let us know how we're doing. It works on your computer. It works on your phone. And just let us know how the pizza is. We've been keeping this data for 14 years minus the pandemic. So it's a very rich data set. It's longitudinal because we have repeats in there. It's really good. So let us know how it is. And for folks watching virtually, as always, we like to see what you're eating, if you're eating something. Vikram, you usually help us out. Let us know what you're eating. Anyone else? Let us know if you're eating pizza or dumplings or tacos or pasta or oatmeal, whatever it may be. Let us know what you're eating. If you're watching this online, you have 2 ways you can comment. You can either comment right on the YouTube feed, or you can go ahead and join our Slack group I mentioned earlier at nyhackr.org, and you can go to the monthly Meetup chat channel. And in there, you can chat about the meetup. Speaking of that Slack, if you're watching this virtually and you want to ask a question, put the question either in that Slack channel, monthly Meetup chat, or in the YouTube channel. And at the end of the talk, I will collate any remote questions and ask it of our speaker. For those of you in the room, feel free to just throw something at him when you're ready, and you can ask a question at your leisure. Right? All right, wait till the end.
We'll wait till the end.
Yeah, wait till the end, but still feel free to throw things at him if you feel so. If you feel such. It's his first talk, so we're going to haze him a little bit. Just a little bit. All right?
I can take it.
Yes. All right, coming up in October, we will have Shobik. A lot of you have met Shobik before. He's not here tonight. He's a repeat attendee, repeat speaker. He's spoken at the conference, spoken at the meetup. He'll be giving a talk. We don't know the topic. We don't have the exact date, but it'll be early to mid-October. We will announce that as soon as we nail down a date. Shobik always puts on a good talk. We always enjoy listening to him speak. So stay tuned. We will announce that. Happening later in October, October 27th through 29th, we have the Government Data and AI Conference. Last month, we had the New York Data and AI Conference. It was really fun. The videos will be up in a few weeks once we're finished editing them. All of you will be able to enjoy that. But for those of you that have any interest in the government, whether that's federal, local, state, whether it's county level, whether it's military, whether it's nonprofit, the public sector, that's going to be a really great conference for you. That is coming up October 27th through 29th. The 27th is workshops. The 28th and 29th are talks. It's at Georgetown down in DC and available virtually online for people who want to join us virtually. If you want to learn more, go to dataconf.ai/gov, G-O-V, to learn more about it. And since you are members of this meetup group, you can use code NYHackR, the name of the group, in order to get a 20% discount on the conference, and that goes for both the in-person and the virtual tickets. So if you're up here in New York, or you're in London, or you're in San Francisco, and you can't make it to Georgetown, watch virtually. But if you can come in person, because we serve food. Today's meetup, in between the talk and the question and answer session, we will give away 2 tickets to that conference. We'll give away one ticket to someone in the room, and 1 ticket to someone watching virtually. And you could get either an in-person or virtual ticket, depending whatever works for your life. So you can exchange it for whatever. So just because you get the in-person ticket, you get it for being here, you can always just attend virtually if you don't feel like traveling. All right. We are going to go to the bar afterwards, as always. It might rain, so we're just going to go to White Oak Tavern down the street, one of our regular places. Just so we have a sense of who's coming, can I get a show of hands of who plans on coming to the bar? Let's see, that's 1, 2, that's 3, missing maybe. So what does that look like, 12-ish? Who's better at counting? Right? Where's my actuaries? Right? Can you give me a count of this? 12 people? No? Are you coming to the bar? All right, 12 to 15? All right, cool, thanks. So White Oak Tavern, we'll remind people, but if you can't find it, Google it, and it's easy. All right, nice and easy to do. All right, so not a lot of announcements tonight. We have the jobs, which you'll all post your jobs. You all voted on the pizza. People virtually are going to tell us what you're eating. We have the October meetup will be announced soon-ish as soon as we confirm the room. Oh, speaking of the room, thank you to NYU for hosting us. They've become our consistent hosts here, and particularly George Parrott and Jennifer Hill for making it happen month after month. So, none of them are here, but we can give them a round of applause in case they're ever watching this. And remember the upcoming AI and data conference for government-focused and public sector at dataconf.ai/gov. All right, I think I hit all of our items. So we'll be able to present our speaker with what I think is going to be a very fascinating topic. The only concern is that this topic's constantly changing. It might change while he's giving the talk. Something new might be invented. So it'll be very interesting, and I expect you to keep up with the changing times. Everyone, please welcome a longtime member, first-time speaker, Frank. Absolutely.
So this is going to be model context protocol, specifically how we can use it to architect context to LLMs when we use them. As always, thank you to all of you for showing up, all of you virtually, and Jared, even though he's already got his AirPods in.
I'm checking the audio for the feed.
All good. So the goals of what we're going to be covering tonight, the first goal is just to define what the heck MCP actually is. This is brand new, November 2024, and there are 100 different definitions out there. The second thing we're going to do is we're going to look at the components of what actually makes up MCP. It's not a singular product, it's a protocol that uses a number of moving parts to get it working. And lastly, we're going to dive into how it works. So some caveats, this is specific to LLMs at the moment. This is currently being expanded to more deterministic systems. Not yet, though. It was released very recently, November 2024. So things are changing. Actually, some of the client capabilities you will see later on were released about a month ago. So things are still changing very rapidly. And lastly, if you would like to follow along afterwards, you can go to my personal website, frank-kovacs.net/projects/MCP_NYCR. That will link you to the GitHub repo, to the slides, and to any demo code we have. So quick thing about me, who is this strange man talking to us? That's me. I'm currently freelancing. Prior to that, I was a senior data engineer at a consulting firm specializing in data science and AI implementations. The career path there was a really interesting one. We went from an ETL developer to more of a data science role, and then finally to this new thing called AI and software architecture within AI systems. When I was there, it was about $60 million in client value add, and prior to that, it was a bachelor's and a master's from Carnegie Mellon in Pittsburgh. 2019 and 2021, go Tartans. And lastly, I am local to the tri-state area. So to begin, I put 2 quotes up there about AI. As you're reading them, the first one's very aspirational, and it speaks to the potential of what we can do here. It's really hopeful, it's really nice. The second one comes from a study sponsored by the RAND Corporation, published a few months ago. And the second one, if I'm working in AI, that is keeping me up at night. If you're an experienced open source dev, if you're only using LLMs, it's taking you 19% more time to do things. That directly conflicts with the first one, and it really contradicts everything we've thought about it. And one of the big problems is that LLMs are not, how do we put this? They're not appropriate for certain classes of problems. And they're very slow moving in their training. And that is what's driving a lot of that 19% that we're seeing. So if we're going to think about a basic LLM workflow, it's very simple. There are only two steps. One, we open up GPT, we type in a prompt, and then LLM black magic happens and we get a response. Everyone here knows that there's tokens, it's not really sentient, but for purposes of this, we're just going to say it gives us an answer like a human. I ask ChatGPT, what is the weather in Hoboken, New Jersey? And ChatGPT will give me an answer. For a number of things, that works really well. For very basic questions, we can figure that out pretty okay. The black box works, but there are a number of situations in which it doesn't work. The two big ones that come to mind are tool specification and knowledge cutoff. Knowledge cutoff is the point at which LLMs are stopped trained. So, for example, with all the GPT models, within the meta prompt, there's a date. And what that date is telling you is that we trained this model on data up to and including this specific date, which if your event happened before that date, you are in the clear, you are good to go. If it happened one day after, things start to get a bit hairier when you do that. And the second one is tool specification. So going back to the example, what is the weather in Hoboken, New Jersey? It can give me an answer, which if for most things, if I just want to know what I should wear, that's pretty okay. But if we're in a work setting, if people want to know, how did this come up? How did you get this answer? Saying, oh, I just asked ChatGPT, that's kind of like the new age, oh, I put it on Wikipedia. It's not going to work, and a lot of people might get very angry about that. You need to be able to talk about where these things came from, and it needs to be auditable. Because LLMs are such black boxes, we really need to sometimes say, use this tool and tell me, so that when people ask, well, where do you get this information? Oh, I got it from an LLM that used the Google API to get it. And specifically, when we have these problems, we can think of the three drawbacks that you see right now. The one I want to highlight is the fact that this stuff is very, very time consuming. We can probably all think of ways to get around the knowledge cutoff, like a RAG implementation. We can get around a tool specification problem, but that just takes a lot of time to do. The security is not very good, and additionally, it's just, again, going to take a lot of time to get the integrations right. So this is where the hero of our talk and the subject comes in. We are defining Model Context Protocol as an extension of the client-server architecture pattern that provides a standardized way for models to interact with functions and static resources. What we mean by this is that LLMs, as we see them now, are not just black boxes in terms of implementation. Architecturally, they're also black boxes. They sit alone on an architecture diagram. They might be able to talk to the outside world, but we don't know how. They might be able to look for recent news sources, but we don't know if they are, and we have no control over them. What MCP does is gives us a standardized way to integrate that black box of an LLM into the wider World Wide Web and to specify specific tooling for it. So some use cases we see here, non-proprietary data, non-public APIs, reliable information, those are all bespoke. Additionally, the benefits, more bespoke things. Point number 3 is very interesting that we're going to cover into time permitting. Now for the big one. Give me a thumbs up if you're live and you can see this and you can understand the pieces. Okay, that was about half of the thumbs, so we'll take it. So this is an MCP architecture right here, and the portions that we can consider as actual MCP are the two servers, server 1 and server 3, the clients that we see in green, and the blue box that we're calling the application host. So typically, if we think about this architecturally, we would note that the user on the left-hand side is going to be sending a prompt to the purple LLM. The LLM is going to do its magic. It's going to be a black box, or in this case, a purple box, because purple's a nice color. and it's going to give us a response back to the user. That works for a lot of things. But here, we're actually interacting with the LLM through what I'm calling an application host. So when we're communicating in an MCP architecture, we're not touching the LLM directly. We're touching the application host directly. From there, the application host does some work and it manages the communication between them. Some things to note that we're going to go over later, but that I want to point out now. There's a one-to-one relationship between a server and an MCP client, and the application host is what we're actually interacting with here. So to define MCP beyond the definition I gave, we can consider two avenues. We can have the components of it that we saw on the diagram, and we can have the layers for how it works underneath the hood. As an aside, how many people are familiar with the client-server architecture model? Okay, about half. So the definition on it is here. It's essentially an ask-answer model, where we have one defined persona that's asking questions, and something, the server, whose only job is to answer that question. Think of like an API endpoint. That server, its only job in life, when I put an HTTP request in, it's going to give me an answer. That's its only purpose. And that's really what client-server is. It's establishing that strict separation between the asker and the answer. So going back to MCP, the first thing we're going to consider is the application host. In our diagram, the application host is represented by this light blue box right here. And in this case, it's quite simply the application that the user interacts with. What we mean by this is that when you're interacting with an LLM system, there are two ways you can do it. Either directly through an API or through a GUI. And using a graphical interface is using an application host because it's doing something else besides feeding the request to it. Within the context of an MCP, this has a couple of really nice benefits. The first thing is that a well-configured application host can make this a lot more agentic and can do a lot of the work under the hood for us. And also, this is what the user would interact with. One note on the documentation, a lot of people call this the client. We're not using that word. That's a bad word. This is the application host, not the client. We can think of this as the brains of the operation. So this is what the user is interacting with. This is what performs all the magic. You can see on those 4 labeled arrows things that it's actually doing. And it's managing those clients. The host is doing that, not the LLM. The client is the next component of this. This is a piece of code within the application hosts that actually connects with the servers. So if we look here, when we're saying the MCP client, we are referring to those 2 green boxes right there. An interesting note is that these are typically spawned directly from the application host. And what this means, we get this for free. In most implementations, that's not work we have to do ourselves, which helps a lot with it. And within this architecture, they're accomplishing a couple of goals. The biggest one is that it's negotiating the relationship between the server and the larger application host. We can think of those lines, one going to the file system and one going to the internet one. It's negotiating that, and that is its only job. An MCP client, when it wakes up in the morning, it thinks about its server. It doesn't think about anything else, and that is totally okay, because within the application host, we want things to do one thing and one thing only. So we did the diagram. Because this is a stateful project, we do have some initialization. I left this here mostly for reference. The big thing that we need to note is that the client is the one initiating all of the communication to the MCP server. So the onus is on the application to make it happen. When we look back here, this should be a directional arrow because the MCP server, it's not magic, it's a server, it's waiting for something to talk to it. So what we're doing here is we're saying that the client is the only one that can talk to it. And then obviously we have the steps that it does to do that. So these are what I was alluding to that are brand new. I left them in for the sake of completeness, but typically these are not going to be things that are going to be concerning us in an implementation because it's handled. So actually, before I go on, what questions do you have about the architecture or about that big diagram? Okay, we're good then. So the next component that we have is the MCP server. We're defining this as something that communicates with the AI model. Well, it doesn't communicate with the AI model. See, it's easy to get it mixed up. It communicates with the client, but it exposes that functionality to it by way of the application host. This is where the magic happens. This is where you store your functionality, and this is what actually does the work. Specifically, there are 3 things that the MCP server can have. Some people say it's 4, some people say it's 2. We are calling this 3. Tools, prompts, and resources. The definitions are pretty bespoke, but what we can think of this as, whenever we have an MCP server, it is doing one of these 3 things. It could be doing all 3 of them at once. It could be doing only one of them at once. And this is what we're going to be doing. So you might be thinking, what are the limitations of what we can put on an MCP server? There are none. Generally, anything you can fit within a Python function, that includes API calls, if you want to fetch a resource, if you want to store a text prompt, you can fit all of that within an MCP server within reason. So if we're zooming in at the MCP server itself, a couple of things we need to consider are the separation of concerns and single responsibility. What this means from an architecture perspective is that when we have these servers, there's a lot of potential for just bottlenecks to happen. There are 3 things it can do, and it's going to be called on a lot by the client. So when we're designing these, we can stick everything theoretically within one MCP server, but that's not going to help. With that being said, we can also have a single MCP server for every single functionality, which we could do. I don't think anyone wants to maintain that, and I don't think that's a good idea. So when we're making these design decisions, these are the 2 principles that keep coming back and forth. And this actually highlights one of the main benefits of this protocol, is that if we separate them correctly, we can control them asynchronously of each other. So what I mean by that is if I have an MCP server that handles time conversions and handles time zones, and I have another MCP server that handles the weather, handles what is the weather right now, where am I right now, I can update and develop those servers independently of one another. Meaning that as we're working on making this more powerful, one issue is not going to bring down the entire system. Previously, with a lot of these AI implementations, the thought wouldn't have been put in there. And because of the integration problems, one small change would just bring down everything at once. So in this case, if we architect this properly, we don't necessarily have to worry about those things. Or, God forbid, a server goes down. US East 1 just decides to die that day. We're still good, because we can just spin it up somewhere else, or we're only losing that small nugget of functionality in this case. So we're going to be going to the data layer now. This is just the how and the what gets happen. So the data layer protocol is essentially what's communicated between the server and the client itself. So if we look here, and when we eventually audit on the dev of an MCP server, we're going to see that the communication between client and server is going to fall under one of these 3 things. They're classified by the type of functionality the MCP server has, and we get those methods for each of them. The fact that this is even standardized goes back to some of the benefits of this. Previously, people could probably write something like this, but this is done for us. We know what it's doing, and we know it is done specifically for us, that we have these methods always available at any time. The transport layer, we can think of this as the how. The key takeaways here are that there are two ways to do it. The first one is the standard I/O way. This is just for local development, not a lot of security, and it doesn't need to be secure because we're running it locally on our computer. The one that we want to really worry about is the second bullet point, this HTTP. So this typically takes the form of a POST or a GET request, but that also means we need to handle the authentication as well. So going back to our diagram, if we're thinking about it the authentication is typically handled by the MCP client itself, spawned within the application host, which again is nice because there's a single source of authentication and a lot less we have to worry about. But it's still something we would need to consider and something that should be on our minds as we're doing this. So we're going to do the code demo a bit later, and let's think about the execution steps here. Can everyone see this or read most of it? So when we're thinking about what this looks like, we can think of it into this decision tree right here. The first step, as usual, is that I, the user, on the left-hand side, am submitting a prompt to the system. This can be anything we want, and that's okay. I submit a prompt to the system, and simultaneously while that happens, the client is initiating contact with the servers itself. So once the prompt is submitted, the host client says, hey, I got something here. Let me tell my MCP clients to go get this information for me. So in that initialization between the endpoint of the application host and the clients itself, if we think back to that lifecycle diagram, a big part of that initialization is getting all of those resources, so asking the MCP servers, what can you do? And those messages will take the form that we see in the data layer. So the clients are asking the servers, what exactly do you have? And it gives back to the clients in that standardized form of what it can do. Now, steps 3A and 3B are decently controversial, and I'm really curious to see what everyone thinks. So if we go along the A path, the model receives the tool list. The tool list is what we get from all of the servers that are aggregated that fall under that MCP tool specification. And as a reminder, when we talk about MCP tools, we're talking about things that can fit within a Python function itself. Something that we can put in a well-defined function that we know will work with one input and one output. Within the call to the LLM, so going back to this diagram, in the handshake, we get the tool list. The host client gives the LLM the list of available tools. And then the LLM returns a message as to whether or not it's going to use those tools. What's up?
From the diagram, does it mean like if a better prompt would result a better response?
Not necessarily in a prompt, just in terms of the tools, not about the prompt itself. So, and we'll cover that in the demo. I think I know what you're saying, but not quite. So what that would be is if I ask it a very specific question, if I ask it, what is the weather in Hoboken? And it knows in the list of available tools, it has something with an input of location and an output of weather, it will put forth a request to use that tool, if that makes sense. And how that would happen is a bit of a black box, but that's what it would mean in an agentic workflow. So the LLM would put back a request saying, I'm going to use these tools. From there, the tool call is then made from the host client to the MCP client to the server itself, and then returned to the LLM that would produce the answer with the output of that tool request as part of the answer itself. The value here is that when we're looking through the logs of this, we know exactly where that came from. We know it wasn't some black box. Oh, did it Google it? Did it make it up? Did it just think about that? We know exactly where it came from because we can say the tool call used to generate this piece of data that was used as an input to this action came directly from the tool from MCP server number 1 at this URL, is where it came from. But there's also the notion where if we ask it something, what is 6 feet in inches? It has nothing to do with the weather. We don't know what's going on. So the model in and of itself can just say, I'm not using any of that, and just give you back the answer, which is totally okay. Likewise, a similar process occurs for resources. So we have tools which are analogous to functions, and we have resources which are static data assets. So in a similar manner to where the model in a black box says, do I need this tool? Do I not? The model also says, those resource descriptions you have look really interesting. I want to look more into that. So it sends you back that structured resource call that is then brought from the MCP server to the client, to the host client, and passed into the LLM. If you're thinking about something akin to a RAG architecture, the value here is that the large size of the resources that we might see, whether they're local or in this case, whether they're on the internet, is that they're not within the application host. The application host is typically pretty lightweight and not something we want to bottleneck. But by doing this, we're saying that it's available and we're automating the connection to the LLM. But we're not worried about storing that locally because that would get very expensive very fast. And this portion also, again, highlights one of the big benefits that we have in this, is that everything that's going on here, none of this is particularly groundbreaking. We all know how to connect resources together. We all know how to do that. But this gives us a standardized way to do it where we don't have to worry about a lot of these other things. And likewise, if it does not want to use the resources, it's just not going to use the resources. If it does, it's going to put through that request and then get it in there. So to zoom in a bit on step 4 in terms of what's returned, so we talk about the step from when the LLM says, I'm going to use this. How it knows to do that is what's initially passed in would follow this specification right here. So when we're making this on the SDK, there are 4 main things we need to fill in. We need the name, the title, the description, and if you're a tool, you need essentially the function signature. What this does is this gives the LLM a description of what it is. Because if we think about it akin to a person, even though we know it's not a person, it's going to be going off the description and the title as to whether or not it should be used. So in some cases, depending on what model you're using, if I have a weather tool that I can use, location input, weather output as a text description, if the long description I provide for it in the specification says it's an NFL player data tracker, it might not use it. And that's one of the blessings and one of the curses, because it's going to be relying on this as to whether or not it's good or not. And typically you want these to be long, but not too long. So much like with the regular prompts that we're using, this is a constant balancing act of how we define these tools within the server. So as an example of this, we can see a screenshot from Claude Desktop on my local. If we look at the question right here, the question is, get any weather alerts for New Jersey. We see where my cursor is right now that it was thinking, it returns this to me, and then I get this pop-up. Claude would like to use this tool, get alerts. Get alerts specifically from the weather MCP server that I have hooked up to it. So I can allow it once or I can allow it all the time. And this is an example of what's going on in that step 3 to 4 of this diagram right here. So in the case that we saw in that screenshot, The model is deciding to use the tool, which is fine, that's good. But now we know exactly what tool it's using, we know where it was written, and if your boss asks, where did you get this? We know exactly where it came from, and we know that to a T. Another example of this is if I ask for the latitude and longitude of where I went to high school in New Jersey. What is the latitude and longitude of Seton Hall Prep in West Orange? The answer it gave without MCP was actually correct, but it grabbed that from Wikipedia, which isn't really going to help us at all. So again, even though it would give the same answer in some cases, that's okay, because rather than saying Wikipedia, I can say this MCP server that's built on top of the Google Places API. And that's step 3 and 4 decision making, whether or not we're going to use the tool or not. That does open up a really interesting can of worms. So raise your hand if someone has tried to talk to you about agentic AI.
I had no idea what they were talking about.
And everyone means something different when they say it. So what they mean by this is that it means treating the LLM like the black box that it is, noting that it's non-deterministic, but also giving it, quote, power over it. If we think back to this construction on line 32, we can consider this as agentic because in step 3, we're just giving it the wheel. We're saying, here are the tools available to you. Do you want to use it? As a prompt form. And it's going to give us an answer, yes or no. So in this case, we're letting it operate like an agent. We're letting it do the work and it make the quote unquote decisions. In a workflow case, we can think of it more like an ETL process. In a workflow case, the quote unquote brains of the operation would be a more traditional orchestrator like an Airflow. So if we want to think about MCP as a workflow, this would actually be done in the client. Steps 3A and 3B would not exist. If we wanted this there, going back to this diagram, we would modify the application host code and force it to use those tools when we get a prompt of a certain type. So what that would mean is that, say we wanted to move towards more of a workflow setting, what we would do is we would say within the application host code, but not the client code, we're not touching that. What we are saying is if prompt resembles X, call this tool, feed results of that tool into the LLM itself. So we would be handling those middle 2 arrows by itself if we wanted a workflow automation. Most of the implementations that we see now for an MCP architecture, most of them are agentic, meaning that steps 3A and 3B are still applicable here. So before I get into the demo, that was a lot of information, a lot of slides. So I'm going to take a pause right here. What questions do you have?
In your decision tree, when the model does not use the resources, so it still provides an answer.
Yes.
How do you have a way to know if it did not use the resources?
Yes.
It just came up with a
Yeah.
answer that's not kind of compliant to the framework that you gave it.
Yeah. So the question was, I don't know if they could hear it at home. The question was, do we get an answer back from the LLM if after steps 3A or 3B, the model says, we're not using that tool, we're not using that resource? The answer is that yes, we do get a no answer from them. And that's ultimately something that we would have to anticipate if we want to make it agentic. Within our prompt, we can heavily encourage it to use it, but it doesn't guarantee that we're actually going to get it, unfortunately. But the power here is that within the logs, we would be able to see that the model did not use the resource. Did that answer the question?
Yes.
Okay. Gentleman in the back.
So are there two different interfaces to the LLM? Like one is the MCP server calling the LLM, and then there's one that the blue box there where the host client's calling the LLM.
Can you repeat that? I'm not. I didn't quite get that.
I think
That's a great question. I'm really glad you asked that. So the question was, are these MCP servers calling other LLMs? And the answer is that they absolutely could be. We can't make the assumption that they are. But within this tool, remember, a tool is anything that we can put within a Python function. So we can absolutely write a Python function that takes text input, gives us text output, and as for the body of it, it's making a call to some LLM. So we absolutely could do that, and that would have to be something that we include within the tool definition. In the toy example I'm providing, the answer is no, but there's absolutely nothing stopping us from having an arrow that goes from, say, the file system tool to the LLM, or potentially even a different LLM.
So in the decision tree example there, when the model chooses not to use tools, does it go all the way back to the host client who now calls the LLM that returns the answer? Or is that going to be just, if it doesn't use the tool, it calls the LLM and returns the answer?
That's another great question. So the question was, when the LLM decides not to use the tool, does it let the MCP server? And no, and the answer is no. Following the line here, it gets the list of tools, it gets the user request. If that user request, that middle line is a no, then there is no more communication with the clients, no more communications with the servers. It just goes right back to the LLM. Good question. Did that answer it? Thank you for asking. Yep. Last one, and then we got to get to the demo. Yes?
How do you teach the LLM what the tools do?
So
They can make a decision to use them or not.
So what we do for this, we provide these specifications within the server definitions, where we're essentially saying this is what this tool does. So that's on the end. So that's on whoever's writing the server to do. The really nice part about it, though, is that the person who's writing the server is not necessarily the end user. So I could have one team whose job it is to write these servers, and they're doing that work for me. So then when I connect to their server, I don't have to worry about it. But that's what it's doing. This is all fed into the LLM as a prompt during that negotiation phase between steps 3 and 4 on the A and B tracks. So that's how it would know what's there. But again, the risk of this is that it's relying on what we put in. There's the garbage in, garbage out theory. If we make this absolutely garbage, then the MCP server is going to be garbage, for lack of a better term, if we just put nonsense there. Did that answer the question?
Yep.
Wonderful. Okay. So now we're going to be going to the demo. I do ask for your patience because I have to turn my head this way. So we're going to make this big. Can everyone still see my screen or see the demo? Give me a thumbs up if you can read this. Okay, wonderful. So what we're going to be doing here is we're going to be just walking through a little toy example of what this looks like using a CLI application client. And then we're going to be diving into what this would look like with the more polished application host. So the first thing we're going to do, we need 2 languages here to make this work properly. We need an installation of Node, and we need a source of Python. NVM, we're using the Node version manager to set it to what I set in the repository, and we need a Python virtual environment, which we do in the first step. So let me go to the code itself. Apologies here, because I'm going to be looking over like this. So what we're going to do here, let's inspect it first. So what this script is doing right here, this is going to allow us to see what's going on in the server and look at what those messages might look like. So if we do this, we're going to be getting a lot of really ugly stuff here, but we eventually get this. So this is a GUI representation of what's happening in the MCP server. So let's connect. So sometimes it does hang, which is not good, but that's not the end of the world. Because what would typically happen in this case, we would get a GUI interface saying these are the messages that are being sent to and from the client. These are the messages being sent to and from the end user. and being able to browse what the specifications are. Let's try a different one. Let's try weather. Weather might work here. And if not, one of the really fun parts about this is that because this technology is still so new, that node package, that model context protocol inspector, it doesn't really have support yet for multiple ports. So if that port of localhost is in use, that's why this is not working. But that's the joy of being on the cutting edge of this. So let's see if this works. Okay, so now this is connected. So one thing that we can do, going back to the life cycle, we can actually see what's being sent to and from the server. To help us with the logs, we can list the resources available. And again, we have to remember all of this is just communication between that green MCP client and that orange MCP server. And because it's an ask-answer model, we can say, what are we asking here? I'm asking to list the resources, calling that method. And we're getting this response, there are no resources, which is an answer in and of itself. If we want to list the templates, same thing, we don't have any templates here. But we should have tools on this server. So let's list the tools. And it says that we do have one, this get alerts Python function, where we get a weather alerts from a string location. So when we think back to that big diagram, what we can just think of, it's not just an arrow, it's just a bunch of JSON, for lack of a better term, that's being communicated to and from it. An inspector tool like this is really nice, because I don't know about you guys, when I was writing this, it was horrible having to parse through logs, having to try to think about what are they doing. This gives us a really nice sanity check for what's actually going on under the hood. And again, if we remember nothing else, this is an ask-answer client-server architecture model. So we need to think about what's going on in terms of we get a request to list the tools, and we get an answer from the server because that's the server's only job is to answer things. And we also have in other things, we can ping it, we can do some sampling and elicitations. We can also store some prompts here. I didn't really go over prompts that much, but essentially what it would just be an autocomplete in the application host if we really wanted to do that. So now that we have that, let's go back to the code. Let's cut that right there. And we need to make sure it's done. It is done. So one nice thing that we can do is we can actually look at the client code itself. So let's see if I can find it from an angle. Right here. Can everyone see the code on the screen? Okay. So remember when we said that the application host is not the same as the client? We see that specifically on that async main on line 150. So if you'll notice, there's some command line argument parsings, there's a print statement. So the MCP client is actually instantiated right here. And if we look above, the MCP client is what's actually defined from lines 14 to about 150, which is good. That's the MCP client. That's that little green server that we saw on the architecture diagram. But the application host is this entire file. And again, this application host is not doing much. It's making a connection, it's instantiating a client, it's connecting that client to a single server, and then it's just going to perform the actions for us, which is fine. But if we wanted to make this less agentic and more of a workflow, the magic for that, we might need to make some small changes to the client, but more likely than not, it would be in something that is called in this main function right here. To drive that home a bit further, let's dive into the client itself. If at any point you can't see it or can't read it, just give me a shout and I'll zoom in.
I wouldn't mind one more there.
Okay. Okay, we are craning our necks here. Let's see, we're gonna do it. Where's Zoom here? You know what we're gonna do? Is this better? Okay, yeah. And yes, I did use the help bar for it, but things stink when you're doing it live. So if we look at the methods of this class instance, we can see it follows that life cycle diagram that we discussed before. And we remember in that life cycle diagram, everything was done, first of all, by the client. We did have to initialize everything, and then finally we need to have a nice teardown process. So the first thing we're doing, we are just instantiating the class, regular init method. We have this connect to server, and there are pretty standard ways to do this. This way does represent a standard way. So quite literally here, we get a path to a local script, either a .py or a .js. We bring it in there. We establish the transfer protocol from the transfer layer. In this case, it's standard input output because we are doing this locally. And we get a client session right here. But also when we connect to the server, because remember, in the initialization, a big part of that is a negotiation between the MCP client and the MCP server saying, what do you have? This is what I have. And this is where that happens. So if we look at line 53, so what we're doing here is this is the client asking the server, what tools do you have? Because under the hood, this is just that list tools method that we saw from the inspector. And then we get the response tools, and then we have this just as a print statement, just so we know what it's doing. We know that the MCP server has this tools. And remember, because the green clients are one-to-one with the server, we only have to ever worry about one server within one client. If we wanted to connect to a second server, we would need to instantiate the client a second time. So 2 instances of it. From here, we have the method where we actually process the query and we're actually using the available tools. So in this case, we're just getting our message started. We're listing the tools. We have the available tools right here. And if we remember back to your question where you asked, how does the LLM know what to use? It gets an answer that is quite literally this, just a JSON, the name, the description, and the input-output function specification, so the LLM knows what to call. We can do the same thing with the resources as well. We give it the list of resources and that. And the nice thing right here is this is something that Claude has built in, where you actually just provide it the list of tools it's specified in that format within the very first call to the LLM itself. As of now, this is a pretty Claude-specific implementation. If we were using another LLM like GPT or Grok, if you go on that side, then what we're going to do is we would just insert it as a prompt. So within the prompt that we have, -- new line, these tools are available to use. This one, this one, this one. And one other thing I want to point out here is we want to note that not a lot of information is being passed along. Just a 3-fielded JSON, what's the tool's name, what does it do, and what form do I need to put it in if I want to use it. That's it. We're not giving it any authentication info. We're not giving it any errata. We're not giving it any debugging. We're handling all of that, and we've separated that out. So if we want to think about how to handle this, we're just giving it only what it needs to know, which from a security perspective is really nice. We're giving it back. Then when we get the response back right here, this again alludes to that flowchart. So starting at line 94, for content and response content, if we get a content type where it just gives us a text answer, we know that it didn't use it. We can think of this as that Boolean you described, is it using it? The answer is no, and we know it's a no because it gave us that. So that is the answer that we're getting, no, and we just append it and we move on. But if the content type it gives back, it's going to give back potentially a little bit of boilerplate text, but the big thing it's going to give back a function call. Specifically, it's going to give us a call that resembles this input schema that we extracted from the tool list on line 71. And it's going to be doing this. And if we remember from that diagram, when the LLM gets the list of tools and says, I want to use that tool, the request goes to the application host itself, goes to the client then asks the server, what are we going to do here? The server gives the answer, and it goes back down the tree. And again, this is one of the best benefits of this. All of those steps are independent of each other. We can see the code. There's not any logging going on. There's not a lot of scary stuff going on. Information is not being shared widely between all the pieces. And that is perfect when we want to architect something like this. Lower blast radius, we are good to go. Then we make the tool call, and then finally we get ourselves the response. And finally we have the chat loop, which just says we're going to keep going until the user says no. And lastly, to make sure that we are hitting the workflow appropriately, we're just going to exit the stack. So that was a lot. Let's try a demo. One interesting thing about this is that because this is non-deterministic, there is no guarantee that it's going to actually use the tool even though we want it to, which is a blessing and a curse. So I have an output just in case this does not want to use the tool. I think it will. So what we're going to do here, we're going to run, let's see. So we're going to run this with just server.py. So what we see here, we see it's initializing the MCP client. We see it's processing the request to list tools. And we see that the tools available to us are get latitude longitude, or as I've described as a function named getLatLong. In the actual description of this, actually, let's pull up that description, because we can. Someone holler if I'm over the servers thing, and we're going to go to server. Okay, so quite literally, I left out a description because I was lazy, but in case of no description, the title does work. So this is literally all that's under the hood right here, where we're fitting it within a Python definition. We're calling a helper function that lives locally, and quite literally all this is doing, this is calling the Google Maps API. That is saying, give me the latitude and longitude, or as they call it, geocode, for a text location. So it means I can put in something like New York University, and it's going to give me a latitude and longitudinal dictionary, which is good. And this, again, we want to think of a tool and some of these functionality as just a regular old CS function right here. So this, quite literally, 29 lines, that's all the server is right now that we're going to be running, and we have it. So what is the latitude and longitude? Someone give me their favorite spot. If not, I'm going to say New Jersey, so someone's got to give me something.
Ribalta.
It's something that I can spell.
R-I-B-A-L-T-A.
Okay, R-I-B-A-L-T-A?
Yeah.
Okay, so what is the latitude and longitude of Ribalta? So we see that it's thinking, and let's wait until this is done. Okay, so here is the thing. So let's look at this. Can everyone see what's going on in the logs right now? Give me a thumbs up if you can see it. Perfect. So what we see here, what is the latitude and longitude of Ribalta? So if we look at the logs of what's going on, as per the lifecycle, it's listing the tools that we have, it's listing the resources. Then we can see right here, starting from where my cursor is, it is what this is doing. If we want to go back to the client code, what's highlighted below is what is going on. We're in the line 98 case right now, where it's a case of a tool use. So it's saying, I'll help you find the latitude and longitude for Ribalta. Let me look that up for you, type text. And then there's also that tool block use right below that, where it is calling that, and we see that it's not only calling a tool, we know exactly what tool it's calling, get latitude, longitude. And then calling tool, And now it's saying that this is what it got. That's what it got, and we see that that answer is put directly into it. But there's more. I could see some of you laughing, but our AI overlords got us. However, I'm not familiar with the place specifically called Ribalta at these exact coordinates, and it gives us some sort of caveat, which is fine. But again, what we want to point out, a couple really cool things happened here. The first thing, we were able to demonstrate the life cycle of this. We were able to demonstrate the life cycle specifically of that client-server relationship. And also for the fact that from an auditing perspective, we know exactly what this is doing. This isn't so much of a black box anymore. We know that it's a black box that's also working with the geolocate API. And specifically, if we want to look at an earlier example, looking at about line 27 on the top half of my screen, I asked it this afternoon, what is the latitude and longitude of Seton Hall Prep where I went to high school? And it tells us that. Same thing. And because it's a bit more of a well-defined place than whatever the heck Jared said, we know that it gives it to us in nice, neat format right there. So before I move to Claude Desktop, what questions do you guys have about this? Because again, a lot of moving fast things. All this demo code is available online after the fact. In the back?
It was spot on.
What?
That's the exact latitude and longitude.
Yeah. Oh, I know. I wrote this. I know. Yeah. Okay. In the back? Hold up, Jared. Why are we using what? Node. Oh, so what we're using Node for, we're using it for that inspector tool. That was a great question. To the people at home, if you didn't get that, the question was, why are we using Node in a primarily Python-based repo? And the answer is because Node, two reasons. The first one is that Node is what that inspector tool is written in. That currently doesn't have a Python implementation yet. The second reason is that we can actually have servers written in other languages that are not Python. And one of the most common ones, because it is a web technology, is JavaScript and Node. So if we look here in the Scratchpad folder, we see that this weather.js. So what we see here, this is the same server that we had before, but it's written in a completely different language. So if we wanted to inspect this server, rather than npx blah, blah, blah Python, it would be npx blah, blah, blah Node. And then if we wanted to run this locally, we can still have the same application host in Python, but we would have to account for the fact that the server itself is in JavaScript. Yep.
So it's not necessarily that the tool requires non-block IO, it's just that the implementation is happening.
Exactly. Yeah. Yeah. In a if we really want to keep it slim, we wouldn't be using Node. You don't have to, but I like to have them in my MCP environments just in case. Really good question, though. Did that answer it? Okay. What other questions do you have before we move to the desktop implementation? No, nothing? Okay. So we are good then. So we are going to be moving to Claude Desktop. Let's see if I can find it. I can't. Okay. So did I spell Claude right? Okay. So what we're going to do, Frank returns. So before we do anything else, let's go to our settings right here. And we're going to go to developer. So that's the really nice thing about Claude, and it's also part of that first move advantage, because the people who use Claude and who maintain it are the same people who came up with this protocol. So we have this nice thing right here, and we see that there are two MCP servers connected. One is TimeNode MCP that I just got from GitHub. It worked really well. And the other one is this weather right here that we see. And actually, before I actually demonstrate this, this right here, this Claude, this is an application host. If anyone calls this an MCP client, I'm going to cry. What is on screen right now is an application host. You might call it something different, but that's what it is. So we see that we have 2 of these available, and both are running locally. We can also put them to something remote, but I have them running locally for this. And if we want to know how easy it is to get there, let's go back to the code and let's actually look at this configuration file right here. So this is what Claude is reading when it's coming up with those definitions. And quite literally, JSON, very easy for us to do. 2 fields. The first one is going to be the command. We are sourcing this from the virtual environments that we're using. Much as the question in the back said, the time node one is actually written in JavaScript. So we're calling the specific version of node that that server is in. The reason why we do this locally is because when something's running remotely, that main command is going to be running all the time. And what that main command is, we don't know, we don't care. But locally, when we have control over it, we need to be hyper-specific. So it's just saying we're going to run this node with the built-in client that we get for free from Claude Code on this index.js file from time node. And likewise for weather, what we're doing here is we're pointing to a virtual environment I made previously for that specific server. And we're saying we're going to use that Python that's stored in that virtual environment, and we're going to call this server file right here. And if you're wondering why are we using absolute paths, the answer is that the stuff is about 9 months old, and they don't really have that configured yet, which is fine. Or if there is a way to configure it, it's not very easy to do and not really worth our time. So that is all that's going on under the hood. So pretty easy so far. And then we're going to go here. So time node. So let's say someone give me a time of an event you have coming up. Date and time. I promise you don't want me to do it, so.
As in name an event or name a time?
No, just name a time.
Midnight.
Midnight. Okay, thank you. Wonderful. So, so if it is midnight in New York City, what time is it in Japan? So, oh, that's the chat history. That's why you don't do this live. So now we're getting the pop-up again that we saw, where it wants to use the convert time from time node MCP server, which we're allowing once just as a best practice. And if we were to run this where we didn't use the MCP, the answer, again, would probably be the same for simple stuff, but it gives us that armor layer when our boss is asked, where did you get this from? Okay. So now that we demonstrated how that works, let's go back to the slides. So to recap what we did, MCP is not some magic, it's not some silver bullet, it's not covered in garlic, we don't like that. It's just a protocol. It's a protocol that enables LLMs to access things outside of its little black box. When we think about this, we need to think about whether we want this in an agentic workflow or whether we want it in more of an automation type role. The biggest benefit that we get from this is it standardizes everything. Nothing that we've covered here is something that if you give a mid-level engineer a Red Bull, they could probably do. But you don't want to do that. We want to keep this nice and simple. So it standardizes it. If you're looking to implement this in your own workflow, just do the server first and then just add it to whatever your application host is. The client stuff is fun, it's nice, but it's not, you could use your time better elsewhere, and we get, remember, most of that client for free. And finally, the client itself is within the application host. And also some questions I know that are going to come up. RAG versus MCP, retrieval augmented generation versus MCP, those are two different ballparks. RAG is a way to enhance LLMs directly. MCP is the protocol that we use to enhance them. Two different ball games. Is this necessary? No. Is it helpful? Yes. And the last thing is that because this is so new, and in general these LLMs are so new, we don't know if this is going to be the standard going forward. It's the standard at this moment, but there's still a lot of time left. But they do have the first move advantage, and in my opinion, they have a lot of really cool stuff going on. So, thank you. Okay, questions? Gentleman in the back.
Thanks, that was really good. So does this like presuppose that we're making utilities to use from, to call from within like a LLM platform? Because like, I can call that Google API to get a lat long from string. If I was like writing pure Python or doing like making a web application, I don't need to go through all this.
Right.
To make use of that API, but like is the purpose that if I want to soup up my instance of all these things, that's what it's going to be.
Yep, okay, so the question was that in the example that we used, why not just use the Google API directly in Python? That was your question, right? I'm framing this correctly. Yeah, why do we do this? The answer is for the toy examples, you could probably just use it in the code. The real reason why that we're doing this is to soup it up for those more complicated problems. So for example, if you ask it to plan an itinerary for you with outfits that you would want every day, it would obviously need the temperatures of those days, and it would need the latitude, longitude to give you directions. So really the use of this is for a lot of those more complicated workflows rather than just the simple ones.
But for that, wouldn't I have to, like, if it's like I'm going to Spain for a week and I want outfits, like, don't I have to in Python or some other way, like, create that whole the problem statement in code? Like, I'm thinking it's turning into like object-oriented programming and design patterns with little calls to these MCP services. Like the problem, the workflow is complicated. And it's not like I can just generically say in English, I'm going to Spain and I need outfits. Like don't I have to spec that out explicitly?
So that's a really good question. So the question was for those at home, how much do I need to spec it out if I know I'm going to be using it for a complicated workflow? And the answer is yes and no. Unfortunately, yes, there will be some work you have to do. But as we saw when we looked at the Claude configuration file of how we added new things, the work on your end would be pointing it to a server and giving it a starting command. That would be it. So you wouldn't have to write all that yourself. You would just go to a list of available MCP servers and plug it in like a Lego. So there is extra work to do, but not that much extra work. But that's a really interesting point, especially architecturally, in terms of how much do we give each MCP server to do and what's actually needed. And that answer is unfortunately very context dependent. Did that answer your question? Wonderful. Okay, in the front.
This is sort of like a router in a way you could think of it, right? And you, the clients, right? Are you just sort of hard coding specific paths to information that you want?
So if I'm hearing your question right, you're asking, isn't this analogous to a router where things are hard-coded from one person to the other?
It could be hard-coded, right? So essentially the LLM is the default, right? I don't know, like, I don't have the things that are clients, that can be your clients, I know they do certain things, right?
Yeah.
When I don't know what to do, when I'm being asked something that these things don't know what to do, I go to the LLM, and that goes and gets.
So you're
I'm thinking this is just like a big configuration.
That's not far off. It's because there's a lot of, all of these components don't really talk to each other besides the lines that you see, and that's one of the big benefits. So do the MCP clients talk with the LLM? Not at all. And if the LLM doesn't need the clients, aside from that initial handshake where they negotiate their capabilities, the right side of this diagram is not touched if the LLM doesn't need it. So we can think of it as a router just not needing to connect to a certain URL.
Yeah, and that's
Yep.
the default. Basically,
Yep.
that's the default path
Yep.
on
Yep.
the LLM.
Yeah, that is the default. If we think back to this diagram right here, the default that we see right here on paths 3A and 3B is that it just doesn't use it, which is what it would be beforehand. So you're getting an answer that is the same as what you would have got had this not even been invoked. But that's a really good point, that these things don't really talk to each other, and when they do talk to each other, it's in a very federated way, which when I hear that as an engineer, that means less blast radius, less things that can go wrong, which makes me a lot happier, and it means I can sleep at night. Did that answer your question?
Yeah.
Okay. In the back?
I know you were very smart to mention that someone's going to ask you a question about rags, and I apologize.
All good.
I feel like there's a lot of use cases for LLMs that involve data that's controlled by someone other than ChatGPT or Claude. And it was all the rage to use rags to solve that problem. And now more and more you're hearing about using tooling generally, and MCP being a subset of that. Do you have a thought about like how to make that decision, like which way is the best way to go for different use cases, that sort of thing?
That's a really great question. So I'm going to repeat it for the people watching at home. The question was comparing and contrasting the RAG approach, retrieval augmented generation, versus the model context protocol approach, wherein in a RAG approach, we're kind of feeding the LLM new information directly, we're spoon feeding it, versus in the MCP approach, we're just giving it things. And where does that line fall? You're going to hate me for this answer. I apologize right now. It's going to depend on how much new information you need to give it, because ultimately we want to avoid bottlenecks. And if the RAG information is decently small, we can avoid bottlenecks by giving the application host a bit more things to do. But if it's really large, that application host is going to be very slow and not really worth it. But you can actually combine them together, where maybe say like, hey, do I need more information? And then use a RAG rather than just feeding it in there, knowing to feed it in for a series of prompts. Taking advantage of the fact that the application host and the clients are stateful, we can have that information essentially on standby to be used. In general, I did not have the best experiences with RAG, so I much prefer an approach like this. But that is completely personal, and if a client says you're using RAG, we're using RAG. Did that answer the question?
Yeah.
Okay, Jared?
Okay, so two sides of the same coin. Can you use like the MCP servers from Claude's website, and vice versa? Can you have a MCP server hosted somewhere that's not your computer?
That's a great question. So there were two questions. The first one is, can you use an MCP server that sits on Claude's server? The answer, yes. I believe they have a couple of dummy implementations out there that you can connect to. And the second question was, can we have an MCP server running that is not on our home computer? And the answer to that is also yes. It would be a URL and some authentication that would happen within the configuration. For the purposes of this demonstration, and also not sure if I'd be able to get Wi-Fi, I only wrote in the demo local ones, but absolutely you can. Did that answer the question?
I guess the question is, if you're using Claude through the website, can you tell that to use tools, just like you do in the desktop client?
If you're just using the web GUI?
Yeah.
That's a great question. I don't know. We can check afterwards because I only ever use it on the desktop. In the back, in the glasses.
Yeah, can you revisit that question from George before? Because it seems like the MCP server is where you shimmy down the list of tools to make it picks from the description you said, right?
Not quite. So the picking happens in the LLM itself. So we get the list of tools that flow from the server to the client. The list of tools then goes to the host client and is passed to the LLM. So the decision whether or not we're going to use the tools is happening at the purple box.
Okay. So I guess that's why the gentleman in front of me is saying it seems like the MCP server is just passing on list of things.
Exactly. That's all it's doing. It's only doing that. This is client-server architecture. That thing's only purpose in life is to just answer questions. That's it. It's not doing anything more, including that. And your hand shot up way in the back, so let's hear it.
So like, would a suitable use case, just to see if I've got this right,
Yeah.
be for a pizza establishment to be the person on the phone, be the user, and the MCP server would construct the order in a standard format back in the kitchen to say this guy's had some discussion about pizza, what he needs to make is apply with the following topics.
Yes, that would be. So for the people at home, it was a scenario question, specifically where we're imagining the persona on the left-hand side of this diagram as some person calling into a pizza place. So in this case, the prompt would be, have some boilerplate, this is a customer calling into this pizza place specializing in this, and then the text of the customer call. That would be the prompt that we put in. So it hits the application host sends that out to the LLM saying, hey, this is the prompt. Do we think we're going to need any tools available? More likely than not, it's going to say yes. Or even if we really wanted to, we could make it a workflow and say, you need to call these tools. And then from there, it goes to the host client, to the specific server client, to the server itself, saying, hey, here's a function call, create_order with the verbal description of the pizza order. That would be executed on the server and then fed back to the LLM and returned to the user with some other stuff. Absolutely. That's a perfect use case, actually. Yep, and another repeat?
Yeah. When you specify the workflow, do you feed that in like through the available tools channel back into the LLM? How do you basically what you're doing is you're forcing it to use those things.
Yeah,
right?
we're forcing it.
How do you tell the LLM that that's what you want to have happen?
That's a great question. So the question was, how do we force the LLM to use a tool if we want more of a workflow rather than an agentic approach? There are two ways we can do this. The first one is what I prefer, the yell approach, where we just type it into shout key at the LLM, use this, and your probability of success goes up dramatically. The other thing we can do, we can actually modify the application host code, where if a prompt follows a certain structure, we just call the tool ourselves and then feed the results of that call into the LLM. But there is also the scenario of if all we need is the tool call, then we don't even need the LLM, then we're talking about just a regular ETL flow there. So the two things we can do, we can either just include it in the prompt to the LLM, or we can force it to call by calling the functionality directly within the application host, outside of the client. Did that answer the question?
Yeah. But if you're like hardwiring it from the prompt, don't you have to like know every possible?
You do.
Okay.
You do, and that's one of the big risks of making it not agentic, because you would need the application host to be very, very smart. And if you're doing all of that prompting beforehand, then you aren't really trusting the LLM to be an agent or to make those decisions, which defeats the purpose. But in some cases, some extreme cases, it can work out. That's a good question. Thank you for asking that. Yeah, in the front?
Is the MCP the only such a protocol, or is there any other types of protocols?
There are others. This is the most prominent one. I know Google is trying to do something with it. I haven't been up to date on their research, unfortunately, because I've been using this since January of this year. There are others, and I'm sure there will be more developed. This is just the first one and the most prominent one right now. Yep. Jared.
Just trying to say we have 100 questions left.
Okay. Do we have any online questions, Nicole?
I didn't see any.
Okay, solid. Anything else? Going once? Going twice? Okay, thank you.
Thank you very much. Before everyone heads off to the bar, or not to the bar, depending where you're going, remember if you have a job, post it in the jobs channel. Very important. We have about a pie and a half left of pizza. No one leaves until we finish it. Could you shut the door and lock it? But please, seriously, eat the pizza, enjoy it. And then we have our next meetup will be announced as soon as we get the room locked down, George can help us get a room, or Jennifer, whoever can help us. It'll be Shobik talking in either early or mid-October. If you want to go to the conference, go to dataconf.ai/gov, and you can use code nyhackr for a 20% discount. And I think that was, let me just check my notes. I think that was everything. Yes, and if you're coming to the bar, it is White Oak Tavern, which is like a block or two that way. So it's really easy to find, really close. So I'll see you all there. And if I don't see you at the bar, I'll see you next month. Thanks for coming.